Hi students, this is going to be a video that covers bond polarity, and so we're going to talk about three different types of bonds, and that would be polar covalent, non-polar covalent, and ionic bonds. So when we have covalent bonds, the sharing of electrons can be equal, and so you'll see that we have two atoms here. These are going to be represented by circular spheres. So these are going to be the atoms. And then we're going to have these electron clouds here. So these are where the electrons are going to be floating around. So the sharing can also be unequal. And you'll notice that we have a different atom on the left. And sometimes when we have two different atoms, we're going to have two different electronegativities. And so you'll notice that the electrons have traveled over to this side of the molecule. So we're going to classify those types of bonds today. And the first one is going to be a nonpolar covalent bond. This is a covalent bond in which the electrons are shared equally. And so, first example we have is diatomic chlorine. And with diatomic chlorine, you'll see that the two dogs are the same size. And when they have a bond between them, they share electrons perfectly evenly, the same. So all of our diatomic elements are going to have nonpolar covalent bonds. The electronegativity between the two atoms is going to be the same, and they have an equal sharing of electrons. So what I tell my students to do in notes, if you want to just do the first one, have hydrogen bonded to hydrogen, and then I have them draw the electron cloud around hydrogens to show that it's equal. And if you wanted to do one for another compound, you would see that the two are bonded together. This is a single bond here for chlorine, and the sharing of electrons is even. Doesn't matter if it's a double bond either, so we could also have oxygen here, double bonded. And same thing, because the elements are the same, the sharing is equal. We can have polar bonds if the sharing is unequal, and we call this a dipole. Di meaning two, and poles meaning it is a polar bond. It's not a nonpolar bond. So a dipole has two separate, equal but opposite charges. So in this one, we're going to take HF as the example, and we're going to see that it has two different electronegativities, and because of that, it is going to have two different poles of electrons. So the hydrogen has a smaller electronegativity, fluorine has a higher electronegativity, and we get this unequal sharing. And we're going to see this symbol. This is called a delta. It's a lowercase Greek symbol, and it means partial. So we don't have a full-on plus and a full-on minus, because if we had a plus and a minus together, that would be called an ionic bond, but it's not. And so we also will see this arrow. This means dipole. And on the bottom of the arrow, this is where the partial positive lies, and on the tip of the arrow, this is where the partial negative lies. And the sharing, once again, is unequal. So a polar covalent bond is a covalent bond that does include a dipole moment. It occurs when we have two different elements. And so here's another example. H plus Cl, those are the dot structures, and when we combine in a bond, and this is what I tell my students to draw in notes right here. I have them draw the dot structure, but I'm going to show that the sharing is unequal. And we have a dipole. So if I were to draw a dipole in here, it would look like this. Chlorine is more electronegative. Hydrogen is less electronegative. So if we wanted to get real specific, we can actually look at a chart of electronegativities, which is a measure of the attraction of an atom for a shared pair of electrons in a bond. And in Unit 4, we covered the periodic trends. And so using colors, visually we can see that Generally, as you move across a period and up a group or a family, we have an increase in electronegativity. Remember that noble gases do not participate here. And then we can actually use real values in order to calculate, and that's what the next video is going to be about.